So you have the same diagram as what I've given you for worksheet 2, page 9. Okay. The only difference between the two questions is now I'm using copper electrode. So in the earlier worksheet, I say when you are given the electrolyte, look at it carefully. Is it concentrated or is it dilute? No, is it concentrated or aqueous? Now, it is not looking at just the electrolyte. You have to look at the electrode. So the moment you see copper, silver, you have to tell yourself this is reactive electrode. Yeah, so I read myself. When you are looking at an electrolysis question, do not just now look at whether is it a concentrated or aqueous solution. You have to pay attention to the electrode to see whether is it reactive electrode or inert electrode, because the product form will be different. Okay, so if you were to unpack the term reactive electrode, right, it means that the electrode itself will take part in the electrolysis process, meaning it will not stay as the electrode. Something will happen to the electrode. Yeah. Okay, something will happen to the electrode.
Okay. Inert electrode is like reactive electrode.
Okay, now the two electrolyte that's present, water and copper 2 sulfate. So this one very clear cut. Just write it in and make sure you name it, not the chemical formula. What blue?
Solution.
Okay, so the solution is blue, correct. This is a blue solution. Yeah, blue solution. Now, so I'm going to ask you, you have anode and cathode. Only one of it will undergo reaction. You can't have both electrode reacting because then you have a problem. Your circuit will not be completed. The cathode will be the one. Okay, so now let's go back to your two animals that talk about the reaction at the cathode and anode. So you got oxidation at anode, right? Okay. Then your reduction, cathode. Can see this part? Okay. Then I'm going to ask you, can you further unpack reduction and oxidation for me? In terms of electron lost. Oxidation is loss of electron. Reduction is gain of electron. Correct? I've given you two electrodes of the same metal, which is copper. So I'm going to ask you, copper metal itself, does it undergo reduction or does it undergo oxidation?
Sure, reduction lah.
Oxidation, because then Cu plus Cu.
Okay, so now come back to this. I'm giving you copper, right, which is a solid. What can copper form? You can form Cu2 plus, right? So when you form Cu2 plus, is this a loss or a gain?
Loss.
Loss, right? Because you're going to add your electron here. Can you understand this part? Okay, so I'm relating you back to the reaction that can take place at the respective electrode, then connect it to electron transfer, whether you're losing electron or are you gaining electron. Then now I put in the electrode that I'm given. I'm given copper metal. Does copper metal undergo oxidation or reduction? So copper metal can only form positive ion, what? So if you look at this equation that I've constructed, it just tells you that this reaction is oxidation. So now I am going to ask you again, which is the electrode that will take part in the electrolysis process? Is it the anode or the cathode?
I think does it depend? Or is it anode? Oh yeah, carbon or metal.
Yeah, it will only be the anode because metal can only undergo oxidation. You follow what I say? Because metal only form positive ion, right? So when you form positive ion, the oxidation state increases. That explains the reaction. The electrode that will take part in all this type of question will be anode. So only the anode will be reacting.
Is it like completely impossible to have a negative?
Don't have. Metal must be positive.
What's the state symbol of Cu2 plus?
Aqueous. Aqueous.
Okay, never mind.
Oh, sorry. Can you add in aqueous here? Because you dissolve into the electrolyte. Okay. So now, having that in mind, your copper metal is going to form copper 2 plus, right? What do you think is going to happen to this anode?
I don't know.
Is it going to stay like this? What will you see happening to the anode?
Oh, wait, around the bigger volume decrease in size?
It will decrease in size. Why does it decrease in size?
Copper is
Because you are trying to change the copper metal to copper ion, right? The copper ion goes into the electrolyte. So what you're going to say is the size of the anode going to be smaller. So observation, there's a few things you can write. You can say the anode dissolve. So there are some common phrases that you see. So dissolve into the electrolyte. Or yesterday I also talked about, you can say it becomes smaller in size. Or you can say decrease in mass. I'll write it in red. So there's 3 ways they can phrase this observation. Decrease in mass, it just means that it becomes smaller. Yeah. Okay. So explanation. Okay, explanation. You write it in. Copper is a reactive electrode and will oxidize at the anode to form copper 2 ion. Okay? Yeah. This equation I've given to you earlier, can you write it in yourself? It's the same equation I've given to you earlier. Basically, if you look at this diagram, what happened is this electrode is going to take part in the reaction. So, what happened is they are going to be forming a lot of Cu2 plus ion. Okay? So, this one, the one in purple, is the ion that is from the anode. Okay, so just take note. This anode is going to dissolve. They are going to give you the Cu2 plus ion that will be moving around the electrolyte. And at the same time, this electrolyte, because it's a copper 2 plus salt solution, you already have a lot of existing copper 2 plus ion here. So this one is from the solution itself. I have 2 different color-coded copper 2 plus ion. One comes from the anode, one comes from the electrolyte. So the moment you turn on the battery, the whole circuit is connected, electrolysis process starts. That means the ions that will be attracted to the cathode will always come from the electrolyte first, because it does take time for the anode to dissolve to form all these ions. Okay? So if you have one Cu2 plus ion that is being reduced here, then you have one that will replace it eventually. You got what I meant? Okay. Every one Cu2 plus ion, every 1 mole of Cu2 plus ion that is reduced at the cathode, eventually it will be replaced by the 1 mole of copper 2 plus ion formed when your copper anode dissolves.
So this will go until the copper anode disappears?
Yes, in a way. So if you have 5 copper 2 plus ion discharge, it will be replaced by 5 copper 2 plus ion that comes from the anode. So
if the anode finishes, then you have
yes, the reaction will come to a stop. Okay, so my next question. What happened to the concentration of the electrolyte?
Stay the same? Stay the same.
It stays the same. Will you have any change in the color?
No.
No.
Wait,
You got
it's
it?
even more dilute.
how do you, because you say when the anode copper 2 plus discharges, then it goes to the cathode.
No, actually it goes into the electrolyte. It goes into the electrolyte.
Also then,
So usually when the reaction starts, right, all the Cu2 plus ion will be attracted here, but it takes some time for it to dissolve to form the copper 2 plus ion. So this is how it works. Okay? So this explains why color intensity remains the same, concentration remains the same. Got it? Kelvin, you understand this part now?
So it doesn't matter the